Hey, the topic in this video, bases other than E. This corresponds with sections 3.4 and 5.1 in the textbook. Kind of finishing cleaning up all this random stuff we left behind. Well, random and also not so random. After you've seen the whole unit, you're like, oh, there's kind of some cohesion. But it's pretty scattered, some here, some from there, so kind of finishing up the unit with two different sections, differentiation and integration. These rules, again, honestly, don't come up very often on the AP Calc exam, but knowing them, having some familiarity, can kind of help you. Usually they'll be on the multiple choice portion. Kind of seeing the rules, having some frame of reference, can help lead you to a correct answer. So find the derivative of each of the following. Y equals 2 to the x. So we have 2 that are a value. So using the first rule, a to the x derivative ln of a times a to the x. So y prime is ln of 2 times 2 to the x. There we go, just kind of straightforward using the rule to get our answer. Y equals 2 to the 3x, so kind of looking here at a chain rule problem. We have 2, that's a, 3x, the inside, that's u. So kind of figuring out from this rule. So ln of a, need ln of 2 times 2 to the u, so 3x, times u prime, the derivative of u. So there we go. You could clean this up a little. 3 ln of 2 times 2 to the 3x. The 3 in front of the ln 2 could become power, so ln of 2 cubed. So algebraic manipulation, that could become ln of 8, 2 to 3x. Again, remembering your logarithmic exponential rules for rewriting problems. Example C, log base 10 cosine of x. So we have a logarithm right here. So base 10, the 10s are a. Cosine of x, that's going to be u. So y prime equals 1 over ln of a, so ln of 10, times u, so times cosine x. I'm hearing nothing but footsteps. They're just going in figure 8s around there. Good for them. Times du dx, so times derivative of cosine, so times negative sine x. Sine over cosine can be tangent. So negative tangent x over ln of 10. Alright, so just using those rules, really straightforward, using them, getting answers. Example 4, kind of pause the video, see how many of those you could get. Then start back up, we're looking at integration, okay? So this is the section 5.1, I think. Sorry if you're watching this wearing headphones. You can do through headphones, hear me cough, hear me take a drink of water. Drink water, no, drink a tea. Okay. So integral of 2 to the power x. 2 is going to be the a value. So looking at this rule for integration right up here. 1 over ln of 2 times a to the x, so times 2 to the x, plus c. If you know the rule, I have the rule, pretty straightforward, okay? Example B, x squared in the denominator, that's like an x to the negative 2. X to the negative 2 is some form of the derivative of a negative 2 over x, or negative 2 to the negative 1. So if I write that out, 3 to the negative 2, x to the negative 1, times x to the negative 2, all of that dx. Could be a U-sub problem. U is negative 2x to the negative 1. Du, bringing the negative 1 down, so 2x decrease exponent by 1 dx, and du over 2x to the negative 2 equals dx. And I just saw the color switching right here. That's great. Look at those. You can switch. Oh, color there. Good deal. Okay. So, the u and the dx make your new integral. So integral of 3 to the u times x to the negative 2 du over 2x to the negative 2. The x to the negative 2 powers, those cancel out. Could pull the 1/2 on the front. Integral of 3 to the u du. That would be 1/2 3 to the u. So looking at the rule, so 1 over ln of 3 times 3 to the u plus c. So having these rules at your disposal really helps. You can refer to them, use them really step by step, okay?